Imagine constructing a skyscraper. You wouldn't just start laying bricks, would you? You'd need a blueprint. Software development is similar. It needs a blueprint, a plan, a structure. This is where software architecture comes in. Software architecture is the foundation of any software system. It dictates how different parts of the software interact. This includes components, their relationships, and the principles guiding their design. Why is this important? A good architecture makes software easier to understand, develop, and maintain. It's like having a well-organized library. You can easily find the book you need. A poorly designed architecture, that's like searching for a needle in a haystack. In essence, software architecture is the backbone of software development, ensuring robustness, scalability, and efficiency. Just as a blueprint guides the construction of a building, a well-defined architecture guides the creation of robust and successful software. Let's talk about pipes and filters. No, not the plumbing kind. Imagine a system where data flows through a series of components, like water through pipes. Each component or filter processes the data and passes it on to the next filter. This is the pipe and filter architectural model. Think of a manufacturing assembly line. Each station modifies the product, adding a part or performing a specific task. Similarly, in software, each filter performs a specific operation on the data. This model is excellent for tasks involving linear data processing. One real-world example is Unix-based systems. They use pipes to chain commands together. The output of one command becomes the input for the next. Simple yet powerful, the pipe and filter model elegantly handles data transformation in a step-by-step manner. Imagine a group of experts gathered around a blackboard, each contributing their knowledge to solve a complex problem. This is the essence of the Blackboard architectural model. In this model, independent software modules representing the experts work together on a shared data store, the Blackboard. Each module specializes in a specific aspect of the problem. They write their findings and solutions on the Blackboard, accessible to all. Speech recognition systems often employ this model. Different modules analyze the audio signal. One identifies phonemes, another maps phonemes to words, and so on. The results are combined on the Blackboard to form the final transcription. The Blackboard model excels in situations requiring diverse expertise and complex problem solving. It promotes collaboration and knowledge sharing among independent software components. Section 4. Layers of organization building software like a cake. Think of a layered cake. Each layer has a specific purpose and builds upon the one below it. This is the concept behind the layered architecture model. In this model, software is divided into hierarchical layers. Each layer has a specific role and interacts only with the layers immediately above and below it. This separation of concerns enhances maintainability and allows for independent development and updates of each layer. Operating systems are a prime example of layered architecture. The kernel, the core of the OS, interacts directly with the hardware. Above it, layers manage files, networks, and user interfaces, each building upon the functionality of the layer below. Layered architecture promotes modularity and reusability. It's a popular choice for building complex systems, where clear separation of concerns is paramount. Section 5. Request and you shall receive. The client-server model. The Internet as we know it is built upon this model, the client-server model. Imagine a restaurant. You, the client, place an order, the server takes your order, prepares the food and brings it to you. Simple, right? In software, the client requests services or resources from the server. The server, in turn, processes these requests and provides the necessary data or functionality. This model is the backbone of web browsing, online gaming, and countless other applications. When you browse the web, your browser, the client, requests web pages from a web server. The server sends the requested pages and your browser displays them. This request-response cycle forms the basis of client-server interaction. Section 6. Reacting to the world, the event manager model. Imagine a busy control room, constantly monitoring sensors and responding to events as they happen. This is the essence of the event manager model. In this model, software components communicate through events. An event can be anything significant, a user clicking a button, a sensor reading changing, or a message arriving from another system. Components register their interest in specific events and provide handlers to process them. This model is ideal for systems that need to react to real-time events such as air traffic control systems or stock trading platforms. When an aircraft enters a new airspace, the event, the system automatically notifies relevant controllers, the handlers. The Event Manager model shines in scenarios demanding responsiveness and real-time interaction. It enables systems to be highly dynamic and adaptable to changing conditions. Section 7. Choosing the right blueprint for success. Just as an architect chooses the right structural design based on the building's purpose, software architects must select the most suitable architectural model for their projects. There is no one-size-fits-all solution. Each model has its strengths and weaknesses. The pipe and filter model excels in linear data processing, while the Blackboard model shines in collaborative problem-solving. Understanding these strengths and aligning them with the project's requirements is crucial. Choosing the right architecture is a fundamental step in software development. It lays the foundation for the system's success, ensuring its maintainability, scalability, and ability to meet the desired goals.